In this presentation, I'm going to talk about some of the standards that we use for encryption. So I talked conceptually about how encryption works in the previous presentation, and here we'll look at specific standards and really not specific algorithms. We're going to look more at the standards that may use multiple algorithms. We're not going to talk about the specific algorithms as much in this course. That we'll discuss more in something like IT Security 2 or a cryptography class. You might go into more detail with those algorithms. So most of the software currently used to protect the confidentiality of information are not true crypto systems. They're applications to which cryptographic protocols have been added, particularly of internet protocols, which we're going to talk about in this course. So as the number of threats to the internet grew, so did the need for additional security measures. So one common implementation of encryption is HTTPS, which uses the Secure Sockets Layer, or SSL. So that uses public key encryption to secure a channel over the public internet. If you think back to our conceptual discussion about encryption, I talked about how we had to, in order to have an efficient crypto system where we exchange keys, we have to use asymmetric encryption. So SSL is one great example of where we use public key encryption. And if you think about all the things that your web browser does. When you open up a web browser and you go to a website, you don't have to put in an encryption key in order to go to Amazon.com and buy something. Your browser automatically secures that channel. And not only does it do that, but it also tells you that you can trust Amazon.com. And I talked a little bit about how trust works, although that's discussed in much more detail in IT Security 2 and in the cryptography course. So HTTPS, which when you go to a website and you type in HTTPS, you have the S on the end and it's secure, uses SSL, or the Secure Sockets Layer protocol. I don't want you to think that SSL is itself an encryption algorithm, but rather it uses encryption algorithms that are standardized. So it incorporates those algorithms that we talk about. So another example is securing email with SMIME, PEM, and PGP. So Secure Multi-Purpose Internet Mail Exchange, or SMIME, is one method of encrypting email. It uses digital signatures and public key crypto systems, so it's much easier to use than some of the other alternatives. You have privacy enhanced mail, which is proposed as a standard to use triple DES. We don't talk again about the specific algorithms, but it does employ some specific algorithms that we would talk about in another course. And then PGP, which is another encryption standard for email, which is an older standard. It's been around for a long time. But it is difficult to implement. A lot of users find it difficult to use PGP because you have to know how it works, you have to set it up, you have to exchange a key with someone that you're going to implement PGP with, so it does make it a little bit more difficult. But there are certainly ways to secure email. SMIME is probably the simplest of these for a user to implement, but there are other methods. So we can also secure web transactions with SSL and HTTPS, which I just talked about. And again, they use some common algorithms that we would talk about in another course, but this is a standard suite of encryption protocols and a way to implement encryption protocols to allow secure transactions over the internet, to allow us, for example, to use our credit cards over the internet. And your book talks about this in much more detail. Another area of concern with privacy and security is using wireless networks. So wireless networks are especially susceptible to security issues because they're over the air and anybody could pick up those signals. So if we didn't have some kind of encryption, it would be very difficult for us to do that securely. One older standard or suite of protocols for encryption for wireless was WEP, or Wired Equivalency Privacy. It was an older protocol and it was not very secure. So later on, the wireless router companies and wireless access point companies came out with WPA and WPA2, which hopefully resolve some of the issues with WEP. So it's definitely a lot better than WEP. You certainly would never want to use WEP in an enterprise or in an organizational implementation of wireless routers, but something like WPA or WPA2 might be more appropriate. There are some newer generations of standards and protocols for wireless encryption, like RSN, which are not commonplace yet. Bluetooth can also be exploited within a 30-foot range, which sounds like it's pretty small, but think about how many people could be within 30 feet of you. And there are some encryption protocols that can be used with Bluetooth as well. But by and large, when we talk about wireless security, we usually make sure that we're using WPA2 on a wireless access point with nodes that can support that when they connect to that wireless access point. And we certainly do not rely on WEP, which, by the way, was 802.11 network protocol. All right, so we have WEP and WPA2. You can see here that WPA uses a much longer key. The longer the key, the stronger the encryption. And again, that's something we'll talk about in in IT Security 2 or in a class that covers cryptography in more detail. So we can secure TCP/IP as well. One of the standards for doing that is IPsec. PGP is another one. So IPsec is really important to understand and to know that IPsec exists because it's probably the most common tool we use for creating VPNs. So in the previous unit, I discussed virtual private networks, and virtual private networks use IPsec to secure the tunnel between two endpoints. So typically when you're setting up a tunnel between two VPN devices, usually you have a couple decisions you have to make. One is the type of key exchange, Diffie-Hellman being the most common. You have to decide on what type of encryption algorithm you're going to use, like DES, triple DES, AES. And again, we talk about how those work in IT Security 2 and in the cryptography courses in much more detail. And of course, digital certificates are also important with IPsec. But basically, IPsec is a suite of protocols and a suite of standards that support encryption over the public switched internet. So that's one of the ways that we create VPN tunnels, is using IPsec. All right, so this is just an example of the IPsec authentication header and encapsulation security payload header. So as we talked about in the VPN discussion, with VPNs you can either encrypt the endpoints. In other words, so you can have secure endpoints, but you don't secure the traffic between those endpoints. Or you can secure just the traffic, but not really worry about securing the endpoints. Or you can secure both, which is much more common. So this is just showing you from the textbook some examples with that. All right, so PGP, or Pretty Good Privacy, was a crypto system designed back in 1991. It is, I believe, GPG is the open source version of this, but it combines the best available cryptographic algorithms for an open source de facto standard for encryption and authentication for email and file storage. In other words, this is PGP is the open source version, but basically it puts together a lot of these open source standards and protocols into one package suite that you can use for authentication and encryption for secure exchange of information. And again, it does employ both symmetric and asymmetric, as well as hashing. All of those tools are part of PGP that you can use as part of PGP. So like I said, I'm going to talk about the standards and algorithms. We discuss those in much more detail. So in a course like IT Security 2, you will discuss in much more detail these specific, what all these specific algorithms are and where they're appropriate. And in a cryptography class, you will learn how those crypto systems actually work. So the math that's sort of behind those cryptographic protocols.